Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillahir Rahmanir Rahim. Welcome to today's physics class. Today is the third chapter on the chapter 7 of waves and sounds. In the previous second class, we have discussed on some mathematical problems regarding simple pendulum and mass spring oscillator. And we have also provided some definitions regarding different terms of simple harmonic motion. We have discussed what is called time period, what is frequency, what is amplitude, what is phase, etc. Today, inshallah, we will discuss about what is called wave. We will provide definition of it. Then we will discuss about some characteristics and types of waves, categorization of different kinds of waves, comparison between the transverse wave and longitudinal waves, the major two types, classification of wave, and some wave related quantities like amplitude, complete wave, frequency, time period, etc. At first, we define what is called wave. Wave is a type of oscillation that doesn't permanently displace particles but transfers energy from one place to another place. And the particles associated with wave follows the motion of simple harmonic motion. As an example of wave, we can say about a wave produced on a rope or a sound wave. So here we see a boy is producing a wave on a rope that is tied with a tree on the other end. So the particles of the rope is moving upward and downward, producing a simple harmonic motion. The particles are not displaced permanently. The particles actually move upward and downward for temporary time from the point of equilibrium, but doesn't displace permanently. But what happens by this process, energy is transferred from leftward to rightward position. And also in case of sound wave, we see there is a speaker that is producing sound continuously, and the air particles around it are moving to and fro and transferring the energy to the next particle, and this particle is again transferring energy to the next successive particle. By this process, energy is transferred, but the particles again come back to the point of equilibrium. Now we will discuss about some characteristics of wave. For mechanical waves, a medium is necessary for propagation. Most of the waves are mechanical waves. They need some kind of medium, either liquid, solid or gas. But some other kind of waves are called non-mechanical waves, or they're also called electromagnetic waves. They're the exception of this discussion. The particles of the medium oscillate but does not displace permanently. Here we see in case of sound wave, the air particles oscillate but does not move, displace permanently from the equilibrium position. And the energy can be transferred from one place to another place through waves. We know it already. The energy transported by a wave is directly proportional to the square of the amplitude of wave. Now there is a relation between the amplitude of the wave and the energy transferred by the wave. What is the relation? Here we see this wave has a low amplitude, that is why it has low energy, and this wave has high amplitude, that is why it contains high amount of energy. The relation is E proportional A square. That means energy is directly proportional to the square of the amplitude. That means if the amplitude is tripled, made thrice times, then the wave will have a ninefold increase in the amount of energy. If the amplitude is twice times, the energy will be 4 times than of the previous. Every wave has a velocity. Velocity depends on the nature of the medium. The same wave has different values of velocity at different kind of medium. For example, in air of 0 degrees Celsius, the velocity of sound wave is 330 ms inverse 1, while the velocity in liquid water is about 1439 ms inverse 1. And the velocity is more in a tight rope than that of a loose rope. In a tight rope, velocity is high, and in a loose rope, velocity is low. So we can observe this phenomenon in this video.
This is a demonstration of wave speed on a rope. The wave speed depends on the tension in the rope in an inverse relation, well, in a direct relationship, actually. So if we don't have much tension in the rope, wave speed is fairly slow. But as we increase the tension in the rope, the speed increases, and then at higher tensions and yet higher tensions, the speed gets very.
Reflection and refraction occurs for waves. We know about reflection. Reflection is the coming back of the wave by getting obstructed to a hard surface and reaching to the initial position, or by making some angle with the hard surface. That is called reflection. But refraction can also take place. For example, a sound wave that is produced inside the air that can also travel through the seawater or river water and go beneath the water by the process of refraction. And phenomenon called superposition can take place. Superposition is the combination of two waves at the same location. That means two waves can merge together to produce a great effect, or two waves can cancel each other to produce a zero effect. Two type of phenomenon can take place by superposition. Number one is called constructive interference. Here we see constructive interference occurs when two identical waves are superimposed or merged together, which are in phase. Here we see that two waves are now superimposed and which are already in the exactly same phase. That is why the resultant effect is much more higher. The amplitude is highest now. And another kind of phenomenon can take place, that is called destructive interference, when two identical waves are superimposed exactly out of phase. When the waves meet, so here we see the two waves now at the opposite phase. The result is now zero. So they're exactly out of phase and the resultant wave is zero, resultant amplitude is zero. That is destructive interference. Now we will discuss about the types of waves. In one way, we can categorize the waves based on the requirement of propagating medium. So by this process, we can categorize wave as mechanical wave or electromagnetic wave. So what is called mechanical wave? If a medium is necessary for the propagation of wave, that is called mechanical. If there is no propagating medium required, that is called non-mechanical wave or electromagnetic wave. As an example of mechanical wave, we can say about sound wave, as a propagating medium is necessary for propagation of sound. In case of electromagnetic wave or non-mechanical wave, we can say about X-ray or visible light, which doesn't need any kind of medium for propagation, but they can travel also through transparent medium like air or glass. And that is one type of categorization. And the type of categorization is based on the direction of particle movement. We can differentiate waves into two categories. One category is longitudinal and another category is transverse. So what is called longitudinal wave? The longitudinal wave is a kind of wave where the direction of movement of particles is in parallel with the direction of the movement of energy. Here we see the energy is being transferred to the rightward direction, and the particles in the slinky or spring moves rightward or leftward position. That means in the parallel direction of the movement of energy. And another type of wave is called transverse wave. Here we see, if we consider this right side, energy is propagating to the right direction, but the water particles are moving upward and downward, which is exactly at the perpendicular angle with the direction of the energy flow. That is called transverse wave. Now we will categorize some common waves. We have discussed about it. What type of wave is sound wave? In terms of mechanical or electromagnetic, sound wave is a mechanical wave, and in terms of longitudinal or transverse, it is a kind of longitudinal wave, because the direction of particles is parallel with the direction of movement of energy. In case of water wave is also a mechanical wave, but that is a transverse wave. Wave on a slinky or spring produced is a mechanical wave, but that is also a longitudinal wave. X-ray and visible light that is electromagnetic wave, and there is also transverse wave. Here, in case of electromagnetic wave, it is composed of variable electric field and magnetic field, and the a movement of and the oscillation of electric field and magnetic field is at perpendicular angle or 90-degree angle with the direction of propagation of wave energy. Now we'll compare between the transverse wave and longitudinal wave. We know about them already. What is called transverse wave? Transverse wave is the wave where the direction of movement of particles is perpendicular with the direction of energy flow. In case of longitudinal wave, the direction of movement of particles is in parallel with the direction of movement of energy, and the wave travels in form of crests and troughs. In case of transverse wave, we see multiple number of crests and troughs. By producing this, the energy propagates forward. In case of longitudinal wave, we see condensation and rarefaction locations on the propagating medium. A single wave, in case of transverse wave, constitutes one crest and one trough. That means by merging one crest and one trough, we can get a single wave. And in case of longitudinal wave, a single wave is created with a condensation and a rarefaction location. As an example of transverse wave, we see electromagnetic wave or water wave are the example of transverse, and sound wave and wave on a slinky or spring is an example of longitudinal wave. Now we will define some wave related quantities like what is called complete oscillation. Complete oscillation is the phenomenon when a particular point reaches to the initial position from the same direction. So here we see the particles in case of longitudinal wave is moving rightward and then leftward and then coming back to the point of equilibrium from the initial direction. Then it is said to perform one complete oscillation. And in case of transverse wave, the particles are moving upward and downward and then reaching back to the point of equilibrium from the same direction. Then it is said to perform one complete oscillation. Now what is called time period? The time required for one complete oscillation is called the time period. So here we see to produce a single crest and single trough, or to produce a single complete oscillation, the required time is called time period T. What is called frequency? Frequency is the number of complete oscillations every second. So the number of complete oscillations that takes place every second is called the frequency, and the frequency equals to 1 by time period, that is inverse of time period. So from this we find a formula, F equals 1 by T. Now a matter of great importance to remember is when the same wave propagates through different medium, frequency and time period never change, but wavelength and velocity changes. For example, if a same sound that is now traveling through air and then it is being refracted through the water, while that is refracted through the water, the frequency and time period will never change for the sound wave, but the wavelength will increase, wavelength will change. As a result, velocity will also increase. What is called wavelength? The distance traveled by a wave in one time period is called wavelength, that is denoted by Greek letter lambda. In other words, the distance between consecutive two phases is called wavelength. That means in case of transverse wave, the distance between two crests is called a single wavelength, is called wavelength. In case of longitudinal wave, the distance between two consecutive same phase, two consecutive compressions can be said as wavelength of the longitudinal wave. What is wave velocity? The distance traveled by a wave in 1 second is called the wave velocity. From the formula, we can say that wave velocity is the amount of distance traveled by a given time. So if we divide the distance by time, we can get the velocity, and if we take wavelength as the distance, then we should take the time period as the given time. But we also know that 1 by t can be written as frequency. Then we can say wave velocity equals to wavelength times frequency. We have replaced 1 by time period by frequency, and we get a formula wave velocity nu equals to f lambda. What is called amplitude? In transverse wave, the maximum displacement of a particle from the position of equilibrium is called the amplitude. Here, the distance from the equilibrium position to the crest or trough can be said as amplitude, the maximum displacement of the wave from the point of equilibrium. But in case of longitudinal wave, to determine the amplitude is much more complex. But for simplicity, we can say that the density of the compressions of the medium is the amplitude of longitudinal wave. Here we see the amount of the density of the air particles in this sound wave or longitudinal wave is called the amplitude of the longitudinal wave. Is there is more amount of density inside of compression, then it is said there is more amount of amplitude. So let's revise what we have learned today. We have defined wave. What is called wave? Wave is a kind of oscillation that transfers energy from one place to another place. It can transfer energy through a medium that will be called mechanical wave, or it can propagate energy without the help of any propagating medium, that will be called electromagnetic wave. We have also discussed about some characteristics of wave. Wave has a velocity, and velocity of wave changes from medium to medium, and particles are not displaced permanently, etc. And we have also discussed types of waves. We can categorize waves in two categories: mechanical or non-mechanical waves. We can also categorize waves in longitudinal wave or transverse wave. We have also compared between the features of transverse wave and longitudinal waves, and we have also discussed some wave related quantities like what is called wavelength, what is called amplitude, what is called wave velocity, etc. So at the end of today's class, you have a homework. Compare the features between the transverse wave and longitudinal wave. আজকের মতো ক্লাস এখানেই শেষ। সবাই ভালো থাকো ইনশাআল্লাহ। সুবহানাকাল্লাহুম্মা ওয়া বিহামদিকা আশহাদু আল্লা ইলাহা ইল্লা আনতা আস্তাগফিরুকা ওয়া আতুবু ইলাইক। আসসালামু আলাইকুম ওয়া রাহমাতুল্লাহি ওয়া বারাকাতুহু।